You might have heard that artificial intelligence is gobbling up resources in the form of water and power, and it's causing a global race to build more energy capacity. But have you ever wondered why? Or what we're doing to bring compute power and sustainability closer together? To dig into these questions and more, I'm joined on stage by Caspar Høgh, a co-founding partner at Noon Ventures, Yasser Nour, the CTO and co-founder of Lotus Microsystems, and by Ruben Bryon, the CEO and co-founder of Datacrunch. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in US cities.
As the disk rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte empty core. I present to you Electro, the Moto Man.
Ladies and gentlemen.
I would say that one of my greatest skills is my ability to interact with humans.
This episode was taped at TechBBQ. It's the largest tech conference in the Nordics, held in Copenhagen, Denmark. How do you collaborate with AI? Miro's Innovation Workspace is an intelligent platform that brings people and AI together in a shared space. Teams can work with Miro AI to turn unstructured data, like sticky notes or screenshots, into usable diagrams, product briefs, and data tables in minutes. And you can quickly build on your ideas without needing the perfect prompt. The work you're already doing on Miro's canvas is the prompt. Help your teams get great done with Miro. Check out Miro.com to find out how. That's MIRO.com. Thank you so much for joining us. It's a delight to be back in Denmark for this lovely conference. My name is Jennifer Strong. I am a journalist based in New York City. And before we get started, I'm going to have everybody else just give a little bit more of an introduction. Caspar, you want to start?
Yeah, I can start. Hi, my name is Caspar Høgh. As you can maybe tell from the accent, I'm a local. I run a venture fund here in Copenhagen called Noon Ventures, where we invest in deep tech across multiple technologies or an array of technologies, amongst others semiconductors and advanced manufacturing.
Yeah, hello, my name is Yasser Nour. I'm CTO, Director of Engineering and co-founder of Lotus Microsystems. We are designing and shipping power electronics and integrated voltage regulators for GPU and CPU.
Yeah, hi. My name is Ruben. I'm the founder of Datacrunch. So we offer cloud services to AI developers. So we are building the physical infrastructure and the software infrastructure on top of that enables our customers to train models and run those in production.
So we are in this awkward phase of contradictions with technology, right? One of the biggest being that AI has the potential to help us unravel the climate crisis, but first it might actually cause one of its own. So why is that? What can we do about it? What really are the problems to be solved here? And yes, this is a big ask for 30 minutes, but we're going to give it our level best. Caspar, do you want to start just to lay out the macro challenge we're actually talking about here?
Yeah, so maybe it's useful to kind of bring this into sort of layman's terms, because I think you can see the reason that volumes of data centers have gone up dramatically in recent years is obviously because of AI. But if we focus on the data centers themselves, essentially what happens in a data center is that you convert something that comes from the grid, probably like several kilovolts of power, down to less than a volt. You only have to have the slightest bit of resistance in there to generate immense amounts of heat, more heat than I think you can imagine. So you have this problem of the power consumption in itself. So imagine data centers, amounts of data centers are going up exponentially to service the more and more hungry AI applications out there. And you have the problem of massive amounts of heat being generated because of inefficiencies in these data centers. So the problems that, for me as a purpose-oriented deep tech investors, the problems that in the data centers that I would really like to solve evolve around solving the heat issues and thereby the efficiencies, but also trying to find out mechanisms to drive down the power consumptions of these data centers.
Okay, now looking at this from a different perspective, from the technical one, Yasser, what are you trying to solve for? What do you see as the actual core of the problem here?
Yeah, obviously we cannot change the technology that it's being built as a semiconductor manufacturing foundry like TSMC or Global Foundries or Samsung. They are building this kind of deep nanometer technologies. And if we take it from the load perspective, now Caspar laid out the foundation where the power is coming from the grid to the chip. To lay out the problem, we have to start from the load itself. The miniaturization of transistors is slowing down. To have more computation, basically you add more transistors into a chip, and that makes it more power hungry. And you need to run it in a very high speed, what we call the gigahertz, or the frequency that runs in the chip. So if we take it from that perspective, the chips are getting bigger and bigger and consume more power. And then to feed that power, we need to build power supplies as close as possible to the load. And imagining that these GPUs are running between like 2,000 amps, 4,000 amps, having micro ohms resistance between the power supply and the GPU, it basically, nowadays we are burning around 8% or 10% of power, just goes into this sub-millimeter space that makes what we call hotspots inside these platforms. So just starting from the hardware itself to the power supply, that basically we need to bring it even closer, the power supply to the load itself, and hopefully at some point of time they will become one unit. So moving upwards from the point of load to what we call the rack power inside a data center, there is always a problem how to bring this power into a cable, because we are reaching the physics limit here on these kind of conductors as well. So we really need to cool down the whole solution. That basically using more power to cool down the application, it's a never-ending story. So the first bottleneck I think that needs to be solved is if we cannot reduce the amount of energy that is burned into a GPU or a CPU, basically we need to look for where there are losses in this system and try to optimize for it. And we see the biggest bottleneck right now is in how to get the power into the GPU and the power supply as close as possible to the GPU. This is the biggest bottleneck. I think the second biggest bottleneck is how to generate enough power to actually power up the whole data center. And we have seen a lot of stories like many hyperscalers like Google and others, they are trying to build reactors next to their data centers just to have the demand closer to the energy generation. And this is mainly to cut the power loss by bringing the power supply next to it. If we think about the atomic reactor as a big power supply, we bring it closer to the load. So everything needs to be fully integrated into a system and getting as close as possible to the GPU.
Yep. All right, Ruben, so what does all this mean, practically speaking, from the perspective of where you sit?
Well, what matters for us is we deployed this equipment, and ultimately our customer needs to have value from that in some shape or form. And we need to extract as a company like positive unit economics from that as well. So for us, like all of that matters, which is like how efficient we can operate the equipment, but then also how can we leverage the equipment as best as possible to have multiple types of workloads run on this equipment. And that's kind of where then our cloud stack comes into play to maximize the usefulness during the lifetime of these accelerators to the customers. And for example, in our company, the bulk of our equipment is running in Helsinki. So all of the heat losses are actually injected into the grid and ultimately heat up people's homes. So for us, the heat is used in a useful manner as opposed to like the bulk of the data centers, which are more like in southern areas in the US.
Actually, like Arizona. Yes.
Yeah, and if you consider like global warming, 10% of global warming is by the direct heat losses or heat that is generated and ejected into the atmosphere. So it's actually quite an important factor to try to do something useful with this heat before it's lost.
Absolutely. I think when it comes to hardware, it also helps to acknowledge some things which will feel fairly obvious perhaps to some on the stage, but maybe not to everyone gathered here. And that is, hardware is quite hard. It's a physical thing, right? Also, it's not the easiest of the things to fund. It's seen as riskier than perhaps, say, software or something else. So with all of these challenges, how do we accelerate the necessary development in this space?
Well, I guess from maybe starting with the statement that hardware is hard, it's no secret. I've invested in Yasser's company, Lotus Microsystems, so I've been quite close to that journey. But we invest in hardware. And the reason we do that is because I think we've passed the era of where you were able to find meaningful businesses outside of hardware. Maybe we're coming with AI back into an era in where you can find meaningful change in businesses within software layer, but at least for us, we've been through this period of time where you'd had to change something in a meaningful way, you had to focus on hardware. I think specifically for the problem of data centers, if we just want to coin data centers as a problem, and with what Ruben and Yasser kind of said around what it is that we need to solve, I think for us as venture investors, I think it's something we'll continuously try to back. Realizing that it might take longer than building a software business, realizing that it's a different risk profile, but it's definitely something that we're keen on continuously getting involved in.
Do we know where in the hardware stack innovation is most helpful at this stage and what should be prioritized?
Well, when it comes to us, where we are doing optimizations is by stacking as much as possible different types of workloads on the same kind of equipment. So that's where a versatile type of accelerator is very relevant for us to consider, where the same accelerator can serve the function of being part of a training cluster at one moment and 1 moment later be part of an inference cluster that serves, like large language models to customers. So for us, this optimization lies in the software stack, and what can be done in addition to that is in the inference, for example, training as well. Like you've all heard of DeepSeek. They've found ways to make more with the same equipment, perhaps not as much as is claimed, but still these are like quite significant ways to progress and extract like 100% more efficiency from the same kind of physical equipment. And these are kind of optimizations that we work with our customers as well to make the inference faster, ultimately cheaper for the customer, and consume less joules in the data center, providing basically a win-win for both the customer and ourselves.
Also, I would add something here. If we would like to see or pinpoint where we should focus our efforts to get better experience, powering more AI, and more AI is going to happen anyway. But to influence the power consumption of this is basically we need two things. We need to work on the load itself, like how we can do more computation per second. And I think the way that could be beneficial is to look for more ways to compute the power itself. So it's never going to be a GPU and CPU only, but there is TPUs, there is DPUs, so more specialized chipsets to do specific type of computations is key to get the power consumption down, and also to invest a little bit more and be aware of the power supply designs, because this is lagging behind. So we need to invest more money into getting these power supplies more efficient, smaller and more dense, and also, I would say, affordable to be used.
Sure. Yeah. Encourage everybody in the room, if you would please, also send in your questions. I have plenty of my own, but I would love to hear from you what you actually want us to talk about. I'm also curious from each of your perspectives what you consider the single most significant challenge you face right now that you feel like you can make real progress on? Because as we're bringing up a lot of things that are going to be very hard for us to, we're not necessarily going to go solve the VC climate for hardware tonight, but like what are things that are very challenging but that you believe you will individually within your own make real progress on? Yeah,
it's a really good question. I think it's important, first of all, to kind of recognize that we are in a part of the world and where we only have, things are moving elsewhere. So when we talk about the challenge of data centers, I think Lotus Microsystems is an anomaly. I think it's very rare to find someone who's actually playing with the biggest players in the industry out of a startup from Copenhagen. But there are areas, both on the software and the hardware side, that are being addressed right now in the Nordics that we're quite focused on. So there are a number of big questions, but I think Ruben also alluded to the efficient use of heat. And I think that here in the Nordics, we have a strong tradition of mobilizing data centers, especially in the northern parts. And I think we have proven to both be very innovative and also have very sort of solid solutions as to how to solve some of those heat issues. Mm-hmm. So that's one of the problems that I'm very focused on at the moment. I think that there are some good solutions being worked on across the startup ecosystem in the Nordics that will have the potential for sort of global penetration and global impact.
Yeah, I think there is a couple of points that I may raise here. Fundraising is one of them. It's really, really hard to invest in hardware. It takes years and years of development, and some of the investors want to see very fast results. But in hardware, it takes 4 or 5 years of development of each cycle, so it's kind of slow. The second thing is we are reaching a material science kind of limit in the designs that in power supplies and also on the GPUs and CPUs. So I think more innovation is needed, and those innovations need capital to actually invest on those. And it's just a problem everywhere, I would say.
But one that you hope to make big progress on. What about you, Ruben?
Well, I think on a global scale, and from us from the perspective as a species, I think a huge problem right now is that a lot of infrastructure is being built out and all else be damned. For example, XAI building out and then violating local emission rules, basically without having approval, which they probably could have gotten with the current administration quite fast, but without approval, then building gas power plants right on the parking lot. It's kind of indicative of how the US is going about building the infrastructure. So a lot of that rapid expansion is being fueled by fossil fuels. We aim to do it differently. As I mentioned, we use our waste heat to help heat up Helsinki, but we also make sure that we have the power purchase agreements in place, or that the data center has it in place, to make sure that the origin of our energy is 100% green. And there's really not a lot of players in our field doing that. In a way, we're shooting ourselves in the foot because it makes our cost go up, but it also attracts a certain customer that attaches a value to that, as well as it attracts employees for whom that matters.
Yeah, I've not heard of this before, and it makes me very, very happy versus our approach in the US of putting a data center where we're running out of water, and you need significant water to cool these data centers, and where it's already incredibly hot, triple-digit Fahrenheit, and would seem like not maybe the best place to locate some of these things.
And then to add to that, I would say in Europe, I guess it's kind of true for almost any country in the world. There's a lack of a complete supply chain for having high-end silicon manufacturing. The US is spending very significant resources to do something about that, and actually starting to build pretty much latest gen manufacturing capability within their borders. I think it's important for Europe to consider how they can do that as well without burning everyone's tax money into oblivion. So currently, some half-assed projects are underway, but I feel like Europe is creating this incentive for building large infrastructure, but kind of lacking some of the essential pieces to actually be fully self-sufficient in that. Yeah, I think it's important for Europe to consider how can we make sure we have this amazing company within Europe, ASML, who is such a key player in this entire supply chain. How can we make sure that we can actually use those machines within Europe to also make the latest nodes in reasonable volume within Europe?
Now more than ever, organizations need to unleash the potential and the power of their people and AI. Miro's Innovation Workspace is a faster way for teams to turn good ideas into great results. It helps teams accelerate through the full innovation cycle, helping them get from idea to outcome faster. It saves time, it's easy to use, and it's actually fun. For a podcast like mine, we can use it for road mapping. That is, outlining a product plan over time in a visual way with key features, milestones, and release schedules. We can also use it to work on new show concepts. Miro has been empowering teams to transform bold ideas into the next big thing for more than a decade. Now, they're at the forefront of bringing products to market even faster by unleashing the combined power of AI and human potential. Here's how. Teams can work with Miro AI to turn unstructured data, like sticky notes or screenshots, into usable diagrams, product briefs, and data tables in minutes. It's more than just putting a bunch of ideas on a board, and you can quickly build on your ideas without needing the perfect prompt. So you don't have to be an AI master or play with yet one more tool. The work you're already doing on Miro's canvas is the prompt. So you can quickly build on your ideas without needing the perfect question. Help your teams get great done with Miro. Check out Miro.com to find out how. That's Miro.com. All right, so we have a couple of questions that have come in. Is material scarcity in the future also part of your focus for R&D?
For us, that's not really relevant, I would say. Of course, we are very much under the influence of how this scarcity plays out and affects our suppliers.
Right.
But it's hard for us to really defend against that. Like, I think for us, it's important to make sure that we build out sufficient compute capacity within Europe from a sovereign perspective, but it's difficult to try to fix the entire supply chain.
Of course.
Ideally, we would build out a plant and make our own wafers to make our own chips, but that's a bit too far down the vertical for now.
Right, of course, but certainly going to be top of mind with the suppliers and everything else.
Yeah, definitely. But also from my side, in terms of manufacturing semiconductors, I would say it's really important to focus on the environmental part of it. Even if the material is available, sometimes or most of the time, we choose to go for example, processes or manufacturing processes that saves the rare materials. And I would say one example, like in processes, when we grow copper on top of substrates, for example, there are additive processes and subtractive processes, and you can choose which one can save copper, for example, or other rare earth material. So I would say we don't see the effect now, but I think with also the political situation that these materials are rare and it's only controlled by, I would say, 2-3 countries in the world. So with one dominant country on that domain. But I think it didn't hit the industry that much now, and the R&D is not moving to solve this problem at the moment.
Yeah. All right, we have another question, also anonymous. When will power availability become an issue for deploying more AI compute?
If I can take that one. This is very specific for each geography. So the issues around power availability differs a great deal from when you go to North America to when you go to the northern parts of Europe, to the southern parts of Europe, to Africa, to Asia, etc. I think what we can definitely say already now is that the demand from data centers is growing almost at an exponential rate at the time being, which means that we will go into a situation in where I think the projections currently say that by 2050, it'd be 50% of the global energy consumption will come from data centers alone. And that's projecting growth across other areas as well. So I think you could already now see also when you factor in the pace of energy rollout, that we already have issues today. I think if you take the Danish energy systems as an example here, you don't really have an issue right now in terms of energy availability. In Denmark, the main problems are more centered around grid rollouts or strengthening of the grids, which is also the case in most geographies. But I think if you look at the US now, they're starting to realize that they don't have the energy sources that is needed to supply the AI rollout there. I think it's almost, it feels like everyone's been saying this for so long, but I mean, look at China now, the pace of which they're rolling out energy generation across all asset types, be it nuclear, solar, wind. It's just in a completely different pace than what we're seeing both in North America and in Europe. So I think that the problem is very, very acute and something that will need to be dealt with.
Yeah, well, it also depends on what you categorize as the actual problem, right? I mean, within the US, there's a report that came out this morning. You can actually measure the impact to individual families' power bills at this point.
Yeah, for sure.
So $500 a year, depending on what zip code you're in certain areas with data centers and these are also not always the highest income areas within the US, of direct impacts because of the demand on their grid and what it's done to the price of power. Anybody else want to chime in there, or should we take some more? Yeah, Ruben?
Yeah, so the power availability is already a problem today in certain geographies. So data centers are being built in areas where whoever is building them would rather not, but is like seeking the power rather than the perfect location for such build out. And that has also led to like this increase in carbon footprint of data centers on average due to this haste that is ongoing. But that being said, currently data centers are not on a global scale using all that much power. It's in the media a lot, so I think people probably assume that currently more power is being consumed by data centers than what it actually is. But then if we consider, like, say, the year 2050, where a massive amount of the total energy production by mankind might be used for generating intelligence. I think prior to seeing such figures where such large proportion of the energy production would go to that, like I don't really subscribe to that, because I think like when you consider growth of humanity across technological previous revolutions, you would always hit into other bottlenecks into growth. And I think one bottleneck that we are running into kind of as we speak, and definitely in the next 10, 15 years, is just manufacturing capability. And the West, like both Europe and the US, have kind of outsourced a lot of their manufacturing to Asia. And I think that will definitely become like more problematic in the next decade, because with all this, like with intelligence kind of becoming the next commodity, where is then the next bottleneck to like, how can we find this like crazy GDP growth that is kind of promised of like 10% plus? Like a big part of that will be in building out the other capabilities in securing that. So more energy will need to be also spent on these other sectors. And I think like overall, especially in the West, like nobody's really gearing up for that.
Right.
So I think what really needs to happen to prevent these huge bottlenecks is just to make sure that low-cost power is going to be available for manufacturing and enabling more of this technology back in the West again.
Yeah. More questions come in. Another one, also anonymous. Are there any alternatives to GPUs for AI usage on the horizon?
Well, there's other things happening like Cerebras. There's Grok with like limited success. There's Tenstorrent. There's a whole bunch of other ones. There's also AMD. And then there's what is happening in China, like you have the Huawei Ascend and such.
And actually, Ruben, do you mind if I pause you for a second and just for the room, can you talk a little bit about these architectures? I mean, I think maybe everybody in the room knows that a GPU is a graphics processing unit, right? But it wasn't designed for AI, and really none of these things were designed for AI. So it maybe would help if we, bring up that people are trying to design for AI now. Well, they are experiments. But
I think the common narrative is indeed that like these current accelerators weren't designed for AI, but I would argue very much against that, in that, especially if you consider like the Blackwell architecture of NVIDIA is very, very much designed for AI. Like if you consider the B300, you wouldn't do simulations of astronomy on that anymore. That's completely off the table. Like that has become an ASIC for AI. And then furthermore, like there's a whole bunch of other products in the market, but I think pretty much the only competitor to NVIDIA today is Google with their TPU. So yes, there is an alternative to the GPU, but it's kind of gate-kept by Google. There is rumors that actually might change, and that's extremely promising for a player like us, and ultimately also for any kind of consumer of what trickles down from this technology.
I mean, you also brought up Cerebras, certainly within the States, that's seen as an up-and-coming. They power Perplexity and other things now with their chips that are wafer-sized and do a lot of compute on chip.
I think the reality is now that this market is completely dominated by NVIDIA. And they have a pretty strong defensibility in terms of continuing to do so for the foreseeable future. But it's evident to anyone that there's the margins that they're able to charge on their products right now, is similar to what you would see in a traditional monopoly. So, as you say, Ruben, it'd be good for, you could almost say humanity if you get other players to come in there. I think, from having been part of some of those conversations, that there are some strong alternatives coming, but I think we have to recognize that NVIDIA probably has a 5-6 year head start on all of them, and I would agree that Cerebras is an alternative for very niche case applications. AMD has obviously been trying to get in there for a long time. Google, Amazon, everyone's trying to get in there because it's amazingly profitable. My guess would probably be that the first real alternative would rather come from someone like Huawei in China, partly because of policy, but they've been, largely incentivized to try to develop an alternative to NVIDIA because of the restrictions on trade.
Like, to be honest, I don't subscribe to that. Like, I think Huawei is really far behind, at least from our perspective. And I think NVIDIA has a competitor in the market today, and that is Google with their TPU. So I think it's not impossible. And I think it's also great that NVIDIA has this amazing margins, because if not, then there wouldn't be no economic incentive for anyone to try to do something about it. But I'm not convinced that it will be coming from China.
Yeah, we are pretty much out of time, but Yasser, I'm going to give you the final word here.
Yeah, I think just to answer the question of alternatives to GPU, there is a lot of talking about specialized chips. Even NVIDIA themselves are developing some things which is not a GPU, it's something else. So, but the mainstream gonna be the GPU for a long time. But yeah, TPUs, DPUs, and all of this kind of, we used to call them XPUs, so whatever the X is going to continue, I think, and this is the only way to get more computational per second, to get more specialized into the type of computation that is needed for AI in general. And that keeps changing. Every application for AI needs a different kind of calculations and different computations. And that opens the door for more kind of specialized processing units, I would say.
I don't think we solved anything, but it was certainly a wonderful conversation. I've enjoyed it very much. Gentlemen, thank you.
Yeah.
And thank you all for being here. This episode was produced by me and Emma Cillekens and mixed by Garret Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong.
From PRX.